Get off my baubles.
Gary the Gonk is back for 2025, and this year he is very protective of his baubles.
Get off my baubles.
How protective? Let's take a look at his new security setup. There's Gary. He's got the same PIR sensor we used last year. Whoa, Gary, I don't want your baubles, mate. Alright, chill. Chill, dude. Gary has upped his game for 2025. He's taking no prisoners. He's enlisted the help of the Cytron Maker Pi Pico. Gary, chill, mate, chill. Alright, whoa. I'm just showing the viewers what's going on. Exactly the same code as last year, but it's not. I've tweaked the code slightly. Same triggers, same PWM to control the servo, so there's a PIR sensor down there. I'm not going to get too close or Gary's going to kick off. Easy, son, easy. It's alright, we're all friends, we're all friends. Sensor picks up someone in vicinity, triggers the alarm. Gary's arm goes up to protect his baubles because they are his baubles.
My baubles.
But now we also have an RGB LED in the Maker Pi Pico, and we have a speaker to play some two-tone sounds. Easy, son, easy. Whoa! I'm pointing to the speaker, not you. So there's the speaker. You can turn it off, by the way. There we go. He's protective, really protective, this bauble. So this is Maker Pi Pico. I was fixing 2-3 videos ago. No, 1 video ago. Lovely piece of kit. I said it's a playground for electronics, and it is. And for about $12, it's great fun. Get one with a Pico 2W on, or get one with no Pico solder. Just get one with the headers. Put your own on, and you're laughing. It's great fun. So I've adapted Gary's code to work on this board, which was really simple because it's just a Pico with all the pins broken out. But I've added code for the speaker to play a two-tone alarm sound and the RGB LED, the neopixel there, which is all set up, ready to go. You don't have to do any wiring apart from plugging in the wires to connect external stuff, which is the sensor and Gary's arm. Right, Gary, I'm just going to go, I'm not going to get your bauble, it's going to go near. Chill, all right? Alright, son, see? So there's a servo going. So let's see what code is running on Gary right now and how it all works. Over to the computer. Okay, so this is the code that makes Gary work. It's massively based on last year's code to the fact of I've just added a few lines here and there. So I'm going to go through it line by line and explain what's going on. So top 3 lines are imports. These are Python's way of getting extra functionality into your script. Now luckily, all of these imports are built into the standard library that comes with MicroPython. So we've got from machine import pin PWM. The pin part allows me to control GPIO pins. PWM is pulse width modulation, which allows me to control a digital pin by turning it on and off rapidly, which is used for controlling the servo. From time import sleep is a way to control how fast the software is running. So for example, if I want to have a light on for 1 second, I'd say sleep for 1 second. Import neopixel imports the neopixel module, which enables me to control neopixels, which is on GPIO 28 on the Maker Pi Pico. And that leads us nicely into creating an object called NP, neopixel. And that calls the neopixel module and the function inside of that, or it could be a class, not too sure, I always get those mixed up. It then uses pin to say, right, I've got a neopixel connected to GPIO 28, and there's only one neopixel in that chain. If I said 100, it would control 100 neopixels in that chain. But we've only got one, so there we go. I then tell the code that I've got a servo connected to pin 16. I then create a variable, an object, PIR pin 17. So I've got a PIR sensor, a passive infrared sensor, the motion sensor, or in this case an obstacle sensor, connected to pin 17. Then create an object called servo, which uses PWM to say, right, I've got a servo connected to pin 16. We need to use it with PWM so that we can make the servo move. And then I say I've got a PIR sensor on pin 17, and it's an input. Then I go to setting up the speaker. So the speaker on Maker Pi Pico is connected to pins 18 and 19. So I create two objects, variables, called speaker pin A, speaker pin B. And they are PWM, so I want to control the tones by turning the pins on and off rapidly. And then volume, make it loud. I then do some maths for the duty cycle, so how long stuff is on for, how long stuff's off for. That controls mainly for the servo. That's for the angles, so I know how far to move Gary's hand. The frequency of PWM is 50. Then we've got the bit that controls how we play sounds. So a function, def, we define functions. Define a function called tone, which uses frequency and duration as two arguments, and play a tone at a certain frequency for a duration of seconds. So speaker pin A frequency, let me say the frec, B frequency, and we pass those as we call the function. We've then got the duty, which is the volume, so how loud we want it, and then the sleep duration. I'm going to call that later on, and then we turn the pins off and we don't need them. Okay, a function for a two-tone alarm. This is an alternating one, so we're going to use a for loop 10 times, so do something 10 times. Neopixels calls, so neopixel 0, that's the first one in the chain, it's the only one in this case. And then we pass it a tuple or a tuple, can I remember how to pronounce that? 25500, that means 255 red, fully on, green, 0, it's the second one, and then blue, that's the final one, 0, off. Then we write that to the pixel so it lights up. We then play two tones, so we've got tone 1, which is an A5 note roughly, sleep for a very short amount of time, then we play another tone, E5, sleep for a very short amount of time, then we change a neopixel from red, which was 25500, to 00255, which is RGB. 255 is fully on, so B, blue, fully on. We write that, and then sleep for a little bit of time, and then that's it. That's the function. Then we go into the main loop. So while true, do this forever. So as soon as the Pico is powered up, do this. If the value of the PIR sensor is 1, so it's high, there's no motion detected. The natural state of the PIR sensor's output pin is to be high by default. And then the half duty of the servo means that it will make Gary's arm go down, and it sleeps 0.1 of a second, and Gary is waiting for someone to go near to his baubles. The else condition is activated if the first condition, PIR value equals 1, is not true. So if that equals 0, that means motion's been detected. And that means Gary goes on high alert.
Get off my baubles.
The servo kicks in and he makes his hand go straight up to protect his baubles.
My baubles.
We call the function two-tone alarm. Then when all that's done, so that's got a for loop, remember, it goes 10 times. It then turns off the neopixel. We write it, and Gary goes to sleep for 0.1 seconds. And the loop repeats going back to here. That's it. So if I run this now you can't see this, but you were to hear if I turn on the speaker, definitely. Stand by.
Get off my baubles.
There we go. Easy, Gary. Easy.
Gary wins. Flawless
It
victory.
took my hand off. But there we go. We've got it working. We've got Gary protecting his baubles with a new ultra precision high security system that is foolproof. Gary, your baubles are safe, mate. For another year, no one's going to touch your baubles. Good work. He's very happy about this. Right, that's it for today. I'll see you tomorrow. Ta-da.